Assalamu alaikum. This is Group 4, and we are assigned to a project of designing and optimization of an autonomous vacuum cleaner robot. The last few decades have experienced significant influx of robotic appliances used in household activities. Floor cleaning is one of the most taxing and time-consuming chores, and this is where automation comes into play, taking over jobs where manual effort is necessary. Floor cleaning robot is the best possible technical solution to do this and thus makes life more easier. A vacuum cleaner is an electromechanical appliance commonly used for cleaning floors, furniture, rugs, and carpets by suction. Nowadays, customers are paying appreciable attention to robotic vacuum cleaners or RVC. So, our main objective is to design and implement a vacuum cleaner robot using Arduino Uno, motor, controller, DC rechargeable battery, and ultrasonic sensor to create a best bank of bucks RVC with faster and more optimized than other machine out there in the market. It is our vision to make such a device that can clean dust and small size waste objects efficiently owing to its smart dust cleaning algorithm, which is something new in the cleaning boot technology. When the battery is down, it can automatically go to the nearest charging hub and charge itself. A mapping and tracking system is available in this prototype robot to increase its efficiency. It creates a map of the designed area and generates the cleaning path according to the map. Finally, the area is cleaned with the help of indoor positioning system. Also, it has a system to detect and avoid real-time objects. And here is a block diagram which can easily describe our approach. We will give a DC power supply through a regulator, and an ultrasonic sensor will continuously give feedback about its position. A motor control will drive both the vehicle and the cleaner motor with the help of power supply. And finally, a microcontroller will supervise all the actions. Now my fellow labmate will describe every portion elaborately.
Assalamu alaikum, I am Sakib Shari, ID 1706113. We group 4 really want to thank you our course instructor Dr. Shehla Shahnaz ma'am and Tasnima Afsana ma'am. We have learned a lot in our control project. We want to work further with our control project to improve the project. Let's move to our methodology method. We have used microcontroller Arduino Uno to control our motor. Power is given to our wheel and motor using the LiPo battery and DC battery here. Now we have some of the parts to be discussed in methodology. In chassis construction, we have used a lightweighted body so that the vacuum cleaner remains less weightless. And now we have an ultrasonic sensor here to detect the object in front of our vacuum cleaner. It works using sound wave. We have used a single transducer to send a pulse and receive the echo. The sonar calculates the targeted distance by emitting 40 kHz ultrasonic pulse. This ultrasonic pulse helps our machine to detect object corresponding to color, surface or metal of the object here. Ultrasonic sensor is attached in front of our vehicle and it works really well. Now let's move to our another sector, Arduino Uno Board. We have used Arduino Uno Board, a microcontroller that controls the whole motion system. The Arduino Uno Board basically receives input from the IS sensors and then analyzes the signal. The IS sensor is basically an electrical signal. We have fed a program in the Arduino Uno Board. The analysis signal then goes to the motor driver, whose main object is to analyze the IS sensor. In the motor driver, it is an intermediate component to convert the 5 volt we have gathered through Arduino into 12 volt for the motors to be operated. In the motor driver, it uses low signal to run one motor and high signal to run the another motor. Thus, it controls the direction of the vehicle in front of any object. In motor parts, we need 2 motors. Both are 12 volt, but for tires, we only need 40 rpm, but in case of cleaner motors, we need 180 rpm here.
Assalamualaikum. My name is Saimur Rahman Arnab, ID 1706116. The algorithm of our project is generic algorithm which is done by several steps to find the correct path. At first, the robot car uses sensors and cameras to model the room and also detects where obstacles are. All of this information is stored in the memory. Then the robot figures out the path by which it will clean the room most efficiently. The entire room is divided into some larger global paths, and each of these larger paths is divided into some smaller mini paths. The generic algorithm helps the vacuum cleaner robot to find associate degree economical path and clean all accessible areas from a begin position to an exit position. The goal of the generic algorithm to carry out the operation of cleaning in the most time and cost effective way. The robotic car always calculates how much of the room is remained and how to get to the unclean part quickly. The distance is calculated from the analyzing the data collected from the sensors. And my friend Waidu Jaman will continue from here.
Cleaner can clean the dust and small particles from the floor as a powerful 800 RPM silent motor is used inside it. Eventually, a wet wiper can be attached behind our robot to clean the mud, which can be cleaned by the vacuum cleaner. Application: cleaning the wet and dry floors. A floor cleaning assistant at home and offices can clean the inaccessible areas like underneath of sofas, bed, and table. Small particles can be picked up efficiently. Limitation: can operate only in flat surface. Future scope: the model that is present in the above report can be optimized as much as possible. The recommendations are: the suction part can be automated using programmable logic control for the sequence of operation. The dust can be collected using vacuum removal. Image processing technique can be employed to analyze the surface cleaning efficiency using a high-quality on-board camera. Germless cleaning using UV exposure installed on the vehicle. AI can be implemented to improve its performance further.
In conclusion, this research facilitates efficient floor cleaning with sweeping and mopping operations. This robot works in two modes, automatic and manual, for user convenience. This proposed work provides the hurdle detection in case of any obstacle that comes in its way. The obstacle detection range is 1 feet. RF modules provide wireless communication between remote and robot, and the range is 50 meters. And these are the reference from where we get our idea.
This is the vacuum cleaner on our vehicle. Now you can see the vacuum cleaner can clean the dust of the floor here. We have installed a fan in our vacuum cleaner so that it can clean the floor easily.
To show that our vacuum cleaner does work, here is a video and we can see that the papers are sucked into the vacuum cleaner.
Now we have installed our main vehicle with a LiPo battery and 9-volt DC battery, and we can see from the video that it can easily object the detect it is facing and it is moving its part. Whenever we are placing an object in front of it, the vehicle is moving around, right?